Now the question is, if alpha and beta are the maximum and minimum values of the determinant f of x is 1 plus sine square x cos square x sine 2x, sine square x 1 plus cos square x sine 2x, sine square x cos square x and 1 plus sine 2x. Then match the following. Under column 1 we have A as alpha plus beta power 27 value. Under B alpha square minus 3 into beta power 11. Under C f dash pi by 2. Under D f dash pi by 2. F of pi by 2. And P is 6, Q is R, and Q is 2, and R is 4, and S is minus 2, and T is 0. Okay, first of all, let us find out the det value of this one. That is, given function f of x is 1 plus sine square x and cos square x and sine of 2x. And this is sine square x 1 plus cos square x and sine of 2x. And this is sine square x cos square x 1 plus sine 2x. So the function f of x is 1 plus sine square x cos square x and sine 2x, sine square x 1 plus cos square x sine 2x, sine square x cos square x 1 plus sine 2x. Now here you apply c1 is replaced by c1 plus c2 plus c3, implies f of x will become, if I add all these things, sine square plus cos square x is 1, so 1 plus 1 2 plus sine of 2x, and this is cos square x and this is sine of 2x. And here sine square plus 1 plus cos square is 1 plus 1 2 plus sine of 2x and 1 plus cos square x and sine of 2x. And sine square plus cos square is 1 plus 1, that is 2 plus sine of 2x, and this is cos square x and this is 1 plus sine 2x. Now here I can take 2 plus sine 2x is common, then this can be written as 2 plus sine 2x is taken common. When 2 plus sine 2x is common, it is left with 1 and cos square x and sine of 2x, and this is 1 plus cos square x sine of 2x, and this is 1 cos square x and 1 plus sine of 2x. Here if I apply the row operations like R1 replaced by R1 minus R2 and R2 replaced by R2 minus R3. So this become f of x is equals to 2 plus sine 2x into, this is 1 minus 1 0 and this is minus 1 0. This is 0 and 1 plus cos square minus cos square is plus 1 and this is minus 1. And it is 1 cos square x and 1 plus sine of 2x. Therefore finally f of x becomes, if you expand using this column, that is 1 into plus 1 minus 0 is 1, so 2 plus sine 2x is left. Now here alpha and beta are maximum and minimum values, therefore alpha is equals to the maximum of f of x. The maximum of f of x, if you substitute sine maximum value plus 1, that is 3, and beta is the minimum of f of x. Minimum of f of x is, if you substitute minimum value of sine, that is minus 1 is plus 1. Therefore under column A what we had given with is alpha plus beta power 27. That is alpha plus beta power 27. Alpha is equal to 3 and beta is 1 to the power of 27, that is equals to 3 plus 1 is 4, and B is alpha square minus 3 beta power 11. Alpha square minus 3 into beta power 11. Alpha square is 3 square minus 3 into beta power 11 1 power 11, that is 9 minus 3 is equals to 6. Similarly what we had is f dash of pi by 2 here. First of all f dash of x. F dash of x is equal to 0 plus sine 2x derivative is cos 2x into 2 implies f dash of pi by 2 is equals to 2 into cos of 2 into pi by 2. That cos of 180 is minus 1, so it is equals to minus 2, and the d1 is f of pi by 2 implies 2 plus sine of 2 into pi by 2. This gets cancelled, that is 2 plus sine 180 is 0, that is equals to 2. Now you can match the things, that a value is equals to 4, so a will match to R, and b value is equals to 6, so b will match with p. So A will match with R and B will match with P, and the C and D where they will match with minus 2 plus 2. Minus 2 S and plus 2 is Q. So S and Q. This is S and this is Q. So therefore these are the matchings of C, A, B, C, D.